All right. So this is lesson 6.3. I'm here with T, and he's going to be helping me go through this lesson. And what we're going to be doing is we're going to be talking about, the book's name is called Understanding Proportions. But basically, we're going to talk about everything to do with proportions today. You ready for this?
Yeah.
All right. Thank you all for watching. Please watch all the way to the end, and we've got some good stuff in store for you. All right. So let's start with the definition of what a proportion is. Okay, and this would be a great thing to be taking notes on while you're watching the video. All right. A proportion is an equation, and it's an equation where you have one fraction equal to another fraction. Now, the book's definition is a little more precise than that. It's an equation stating that two ratios, sorry, it's a little hard to read, but it's an equation stating that two ratios are equal. Okay? So look down below here. Take a look at these ratios. Then they look like fractions, don't they? But same idea. These are all proportions because if you look at them, you can see that 1/3 does equal 5/15. This is kind of like what we did back in chapter 3 with equivalent fractions, isn't it?
Yeah.
Okay, so when we wrote the answers down for equivalent fractions, and I write something like 1/3 equals 5/15, when we write one fraction equals another fraction, that is a proportion. So we were actually writing down proportions back then. We didn't even realize it. Okay, 3/7, does that equal 6/14? Well, it does. And the way you can check a proportion is, what do I do to the top by multiplication and division to change it into 6?
2.
Times it by 2. And if I multiply bottom by 2, do I get 14?
Yes.
Yes, I do. Same thing on the first one. If I multiply the top by 5, I get 5. And multiply the bottom by 5, and sure enough, I get 15. Okay, so that verifies that these are, in fact, proportions because both sides are equal. Okay. Now, there's another way to verify that proportions are equivalent to, and that's, remember the crisscross method, where you start at the bottom and you crisscross going up like this. Okay, so 3 times 5 is equal to what?
5.
3
sorry,
times
15.
5. 3 times 5 equals 15 most of the time, and 15 times 1
15.
also equals 15. If these two numbers are equal, they call those cross products, is the fancy name, then it means that the two fractions or the two ratios are proportional. How about this one? Does it work on this one?
Yes.
6 times 7 is?
56.
Try again.
48.
That's 8 times 7.
Oh. 42.
6 times 8 is 48. You're getting there. 6 times 7 is 42. Okay, we want to think and a little bit more carefully before we shout them out. And now, actually, 3 times 14 is a little bit of work, but it turns out it's 42 as well. So that's a proportion. That's a proportion. Another kind that we're going to see, though, T, and everybody, we're also going to see proportions where they give us one ratio, and then they're going to give us a second ratio, but there's going to be a variable in it. Okay? So here's an example of a proportion right here. 3/7 is equal to 12/x. And this is the kind we're mostly going to deal with, and what we're going to be trying to do is figure out what number goes down here to make it a proportion. So let's try this with the arrow method. What do I have to do to 3 to change it into 12?
Multiply it by 4.
Good. So multiply the bottom by 4. 7 times 4 is?
28.
Good. Much better. Okay. X equals 28. And sure enough, if I put that in for x, 3/7 is equal to 12/28. That's exactly correct. Okay, so let's continue with that type of proportion. So here's another example. Okay, oops, I forgot to put a stop in there. But 12/4 is equal to x/5. Okay, now let's try this one using the cross product method. Okay, so let's draw in the cross product. That's what the red arrows represent. And so 4 times x, okay, is equal to 5 times 12. All right. Now, don't even bother multiplying the 5 times 12. Just leave it as 5 times 12. You'll see why in a second. How do I get rid of 4 times x? How do I get rid of the 4?
I don't know.
Well, what's the opposite of multiplying by 4 if I want to get x by itself?
Divide.
Divide by 4. Remember doing these equations?
Oh, yeah.
Now, if I divide the left side by 4, what do I have to do to the right side?
Figure out what it is and then divide that by 4.
You divide this by 4. No, you don't even have to figure it out. Watch. 4 divided by 4, fruit ninjas, and I get x, right? Now, over here, before I even multiply 5 times 12, do you see anything that cancels there? How about the 4 and the 12?
Yeah.
4 goes into both of those. Well, careful. 4 goes into 12 and 4. It goes into 12 3 times. You're right about that. It goes into 4 1 time. And now what do I get? 5 times 3 equals?
15.
15. All right. Isn't that the same thing we got just a second? Oops. All right. All right. Isn't that the same thing we got? Oops, that's not working, is it? That's the same thing we got. No, that was a different problem. Never mind. Okay, my bad. All right, let's finish this back up again. Okay, x equals 15. Oh, and look at that. I did it twice. All right, let's go ahead and play. Here's another way to do the same problem. Okay, 12 over 4 equals x over 5. The first way we did by cross multiplying and dividing. Okay, the second method is what we're going to do is, let me go ahead and erase a little bit so it's not so, no, it's not going to work. All right, let's go ahead and play it. All right, so I'm going to change 12 over 4, and I'm going to reduce it down to a unit ratio, okay, where we have a 1 on the bottom. And sure enough, 12 over 4 reduces down to 3 over 1. Now it's a lot easier to do the little arrow trick, because how do you change 1 into 5?
Multiply by 5.
Multiply by 5. So I multiply the bottom and the top by 5. Okay, and I get 3 times 5 equals 15. So both ways I do it, I get 15. Okay, the first method would be called cross multiply and divide. Okay, and the second method is called, well, it doesn't really have a name, but I say it's using unit rates. So you do unit rate first, and then you do the arrow method, which is really doing equivalent ratios. Okay, and so this is a way we can solve this. All of this is called solving a proportion. What we're doing here is we're solving. We're figuring out what value goes in for these variables up here, okay, to make the proportion work. All right, let's continue on for a second. Okay, there's another kind of question where they're going to just give you numbers. They're going to give you two ratios or two fractions, and they're going to ask you, do these form a proportion? So all you got to do on these ones is either look for an arrow trick, or maybe reduce them both to the same simplest form, or do the crisscross. Any of those three methods will verify that the two fractions, or the two ratios in this case, are equal. So the first one, I think I can probably do with the arrow method, can't I?
Yeah.
What do I do to 9 and 10 to change it into 27 over 30?
Multiply them by 3.
Yeah, if I multiply the top and bottom by 3, sure enough I get 27/30. So is that a proportion?
Yes.
Yes, it is. Okay. Now, just for giggles and grins, let's go ahead and try the other method. If I crisscross here, 10 times 27 is what?
10 times 27 is 2700.
Or, be careful, it's 27 with 1 0.
Yeah.
So it's 270. And 3 times 9 is also 27 with a 0, so it's 270. So are they equal?
Yes.
Yes, they are. Okay. The unit rate won't work on this one because 9/10 is already in simplest form. The next example, what would I do to change 81 into 9?
Divided by 9.
Right, divide by 9. So if I divide 72 by 9, do I get 7?
No.
Not quite. Okay, so this one is not proportional. Okay, and why not? What would have to be on the top? Instead of a 7, we'd need a what up there? 72 divided by 9 is...
We would need a 9.
Nope. We're dividing by 9. 72 divided by 9 is what?
72 divided by 9. 60.
9 times 8 is 72. Yeah. So if that number was an 8, 72 over 81 would be proportional with 8 ninths, but it's not proportional with 7 ninths. That's it. That's the idea. Okay? All right. So what we'd like you to do, we're going to give you 3 sets of ratios, and we would like you to go through each of these and using one of the methods we've talked about, either by using the crisscross method, or by using the arrow method, or possibly by using unit rates. We would like you to tell whether each of these 3 sets of ratios are proportional to each other. Do they form a proportion? So the white one, the red one, and the green one. Are the 2 fractions or the 2 ratios equal to each other? So go ahead and pause the video right now and show your work and write yes or no for each of them and show why. Okay? And as soon as you're done doing that, go ahead and resume the recording. Okay, welcome back. The first one's pretty easy. I'm going to do these all in yellow. Okay, I could multiply the top and bottom by 4, and sure enough, it's going to work. I could also have done the crisscross method. Normally, when I do the crisscross, I go up. Okay, but I'm kind of out of room there. So 5 times 8 will be 40. I'm actually going to write that down here. And 2 times 20, I'm actually going up, but I'm going to write the answer down here. 40. 40 equals 40. So either way I do it, it's a proportion, yes?
Yes.
The next one, I think what I'm going to do is I'm going to use the arrows. All right, so on the top, it's pretty easy to see. 12, to change 12 into 4, I'd have to do what?
Well, divide by 3.
Right, divide by 3. And before I even try to divide 52 by 3, what's 52 add up to? The
7.
digits. 7. Is that divisible by 3?
No.
No, so it's not going to work. If it had been 42, 42 divided by 3 would equal 14. So that messes it up. So this one is not proportional. I guess we should have probably put over here that this is yes. So this was no or not proportional. Okay, and the last one, I multiply, to get from 5 to 20, I can see that right away. That's times 4, right?
Yes.
And if I multiply 8 times 4, it's close, 8 times 4 is 32. It's not 36. So again, this is not, no, or not proportional. If it had been 9/5,
It's almost.
if it had been 9 over 5, it would have equaled 36 over 4. So yeah, it's almost proportional, but not quite. That's it, guys. So you basically have two different kinds of proportional questions. Okay, you got the ones where you have to tell whether the two ratios are in fact proportional, in other words, are they equal? And then you've got the other kind where one of the pieces is missing, and you need to find the missing number and fill it in. Okay, and you have two different methods to handle proportions. Okay, one method is by using the little arrows. That's the way that really is explained in the book most of all. But then you can also do this idea of using cross, multiply, and divide. Okay, that's it. Now we're going to practice these in class tomorrow, so make sure that you're familiar with these concepts. You don't have to be a master of them, but make sure you're familiar with them all before class tomorrow. All right, and before we sign off here, let's go ahead, we'll go to the last slide. And so I want to thank T. I think is this the first video you've been in?
Second.
Second, all right. Well, this is the first one you've been all on your own.
Yeah.
Yeah. So thanks a lot for the help, and thank you to all of you for watching. We'll see you in class tomorrow where we'll practice working on proportions. See you later, guys.
Bye.